Hello everyone, I am Atharva Aggarwal, a BTech third year engineering physics student, and today I will be talking about the photoelectric sensor using an optocoupler. So basically, as we can see on the given slide, there's a basic circuit diagram of an optocoupler where we have two sections. One is the light emitting one and one is the light detecting one. So how they work, what are the basic principles it will follow, that we will see in the slides ahead. So the basic outline of this video will be, I will start with the introduction of the photoelectric sensor, then I will go with the how it works, what are the basic principles it follow. Then there are many different types of photoelectric sensor that you use optocoupler. I will explain each one of them in detail. Then what are the different applications and what are the uses of our sensor, how it is beneficial than other sensors, and also I will talk about the limitations as well as the different innovations that are coming nowadays in different fields using a photoelectric sensor, which also uses optocoupler. So basically, an object can be detected using light via photoelectric sensor, which employs light to do so. This is what we actually already know about photoelectric sensor using optocoupler, and it is also made up of a photodetector and a light source, which are mostly placed in the same unit. They can be placed in different units, but frequently they are placed in the same unit. The photodetector detects when an object blocks the light beam and delivers a signal to the control unit. So basically, if some object basically blocks the light beam, then the photodetector detects that and it delivers a signal to the control circuit, which can decide what further action do we need to take. And that is like the basic working of this photoelectric sensor. So in photoelectric sensors, there's an optocoupler is employed to create an electrical barrier between the detector and the control circuit. So there's an LED which acts as a light source and a photodetector which acts as a receiver, which are separated by a small gap, and this makes up the optocoupler. So in the first slide, as we saw, that there's an emitting section and a detecting section. So the LED is the emitting section and the photodetector is the detecting section. And when the LED is turned on, it emits light that the photodetector detects and converts into an electrical signal. But however, if there is an object between the LED and the detector, it basically disrupts the light, and the same is conveyed to the control circuit to take further actions that we can decide depending on how much is our photo detector detecting, what are the conditions in the circuit. And without it, and hence without a direct electrical connection between the two circuits, this signal can then be sent through the optocoupler to the control circuit. This is how basically we couple two independent circuits together without having a direct connection between them. So now I will talk about the working of the photoelectric sensor, which is very simple and can be summarized in some following steps. So a light beam is directed towards the target item from the photoelectric sensor. Now the light beam, it can be a laser beam, which is an example of visible light beam, as well as an infrared beam, which is an example of a invisible light beam. Our IR beam is basically an example of an invisible light beam, that we cannot see with our human eyes. So, and the next step will be the presence of the target object. If there is an object in between the optocoupler, it will cause the light beam to divert, which will result in some of the light being either reflected, absorbed, or there's completely no transmission of light. Now these characteristics of the target object, like what is the color of the target object, what is the reflectivity, determine the amount of light that is reflected or absorbed. Now the photodetector in the photoelectric sensor picks up this light, that like how whatever amount of light that is either reflected or absorbed, and this light is then transformed in the form of the signal by the photodetector. And now the optocoupler subsequently relays the electrical signal to the control circuit. And also, in order to lessen noise and interference of the environment conditions around us, the optocoupler creates electrical isolation between the control circuit and the photodetector. And the control circuit evaluates the electrical signal to ascertain the presence or absence of the target object, so as to initiate new actions that we have to take based on the present environment of a circuit. The control circuit may tell the user of the object presence or initiate an action such as turning on a motor or opening a valve depending on the application. So this is how an optocoupler and a photoelectric sensor basically works. Okay, so now I will talk about the different types of photoelectric sensors that basically use an optocoupler to detect the presence or absence of an object. There are many types, but I will talk about only some of the most common types. So first is the reflective type. So in this type, the object being detected is situated between the LED and the phototransistor facing each other in this particular form of in this particular way. The sensor recognizes the object when it reflects light from the LED back to the phototransistor. So as we can see in this image, there's a light emitting element and there's a light receiving element, and here's our target object. And now how much light this target object reflects and what is the intensity of the light reflected, that basically tells us about the target object. And that is how we can sense and tell the properties of a target object, as well as whether the object is present or not. So the second type of photoelectric sensor which uses an optocoupler is an through beam type that we have also seen in a laboratory. So in this there's an LED and a phototransistor, and they are basically two independent parts in this sensor and not a single entity as we had seen in the reflective type. They are set up with a space between them and facing each other, as we can see in this diagram. The light beam is broken when anything moves in front of the LED and the phototransistor, alerting the phototransistor of the object's presence. So this is basically a LED light emitting diode is placed here, and here is a phototransistor, and if basically there's a gap between them, and if anything interrupts the light signal, that is immediately transferred to the phototransistor, which signals this to the control unit, and hence the control unit can then take further actions depending on the user's need. So the next type of a photoelectric sensor using optocoupler is the diffuse type. So in this type, the object being detected is put in front of the LED and the phototransistor, which are adjacent to each other in this type of sensor. As we can see from the diagram, there's the emitting element and there's the receiving element. So this is the LED and this is the phototransistor, which are basically adjacent to each other only. So the object is detected when it reflects the light back from the LED back to the phototransistor. Also, when an irregularly shaped or translucent objects need to be recognized, this diffuse type of sensor is frequently utilized. Now, one of the questions that we might have in our mind is how is this type of sensor basically different from the reflective type. So in reflective type, mostly the sensing objects that are placed in front of the reflective type sensor are the one that have almost 100% reflective properties. However, when we have to detect a translucent object which might not reflect 100% of the light and some light might still be transmitted through it, we use the diffuse type sensor. So the next type of photoelectric sensor using optocoupler is the retroreflective type sensor. So similar to the reflected sensors, this form of sensor positions the LED and the phototransistor facing a reflector rather than facing each other. And the light beam is broken when something moves in front of the LED and the reflector, alerting the phototransistor of the object's presence. So as we can see in this diagram, the sensor has the emitting element as well as the receiving element. However, the sensing object is placed between the sensor and the reflector. And how this object basically changes the characteristics of the reflected light in terms of the transmitted light tells us what are the characteristics and properties of the sensing object. Now we have seen that there are many types of photoelectric sensor using optocoupler. However, the one that is best suited for our application will actually depend on many factors, such as the size and shape of the object being detected, the distance between the sensor and object, as well as the required response time. So these are the factors that we need to consider in before we make a decision as to which type of sensor we need to employ for our experiment. So now I will talk about the applications of photoelectric sensors in optocoupler. They have a wide variety of applications in today's world in almost all industry. So the first is in the packaging and material handling industry. So in the packaging and material handling industry, they are used to detect the presence or absence of packages and products as they move along the production line. They can also be used to detect the level of materials in storage containers. So one of the real life examples is of the company Lay's. So as we all know, Lay's is one of the largest companies in the world which makes potato chips. And as soon as Lay's get its potatoes from the farms, they employ a lot of photoelectric sensors in optocoupler to detect the quality of the potatoes that they have got. And during the supply chain, if they find that uh, any of the potatoes does not satisfy their level of quality, then that potato is basically taken out of the production line. And all this is done is using photoelectric sensors in optocoupler. Second is in the security systems to detect the presence of intruders or to detect the opening and closing of doors and windows. They are almost very widely used to store and protect diamonds when connected with an alarm system. So as we can see in this video, this place is full of photoelectric sensors and optocouplers, and it is used for protecting diamonds using optocoupler. And as we can see in this photo, it is used in material handling to ensure the best quality of goods. And this is how photoelectric sensors in optocoupler has a very wide application in today's world. So the next application of a photoelectric sensor using optocoupler is that they are using smoke detecting alarms in malls, aircraft, apartments, almost everywhere. It works on the principle that the presence of smoke deflects the light being emitted, which gets detected by the sensor and triggers an alarm. So as we can see in this figure, when there's no smoke, there's no deflection in the light, and it is a single straight beam. However, as soon as there is smoke, it deflects the light, and this deflection is then sensed by the photo transistor, which basically triggers the alarm uh, and sends a notification to the concerned people. The fourth application is that they are used in bank lockers to provide an extra layer of security, so that any intrusion to the lockers is immediately detected and the information is passed over to the security. So if anyone without prior permission of the authorities try to enter this locker, then this optocoupler will basically detect that there's someone between this optocoupler, and it will immediately trigger an alarm and send the information to the concerned people. And that is how this provides an extra layer of security to the bank lockers as well. So now I will talk about the advantages of using a photoelectric sensor that utilize an optocoupler. Some of them are non-contact sensing. So optocoupler based photoelectric sensors can detect objects without touching them, which makes them ideal for applications where contact may damage the object or where the object is moving too quickly to be physically touched. So as we have already seen in the circuit diagrams, there's no direct contact between the object and the sensors. However, we are still able to sense them, and that is one of the main advantages of a photoelectric sensor using an optocoupler. High reliability, photoelectric sensors in optocoupler have no moving parts, which make them less prone to mechanical failures and wear and tear. This results in a longer service life and less downtime for maintenance. So uh, the third benefit is of higher accuracy. So optocouplers based photoelectric sensors can provide high accuracy sensing even in challenging environment. They can be used to detect objects of various shapes and sizes, and also their variation on temperature is not that much as compared to other sensors. So the next advantage is of versatility. So photoelectric sensors in optocoupler are versatile and can be used in a wide range of applications, such as industrial automation, packaging, security, medical equipment, automotive industry, and consumer electronics. They are not limited to a particular industry or a particular application, and has a very wide range of applications. The next advantage is of easy to install and use. So these sensors are typically easy to install and use. They usually require only a power supply and a connection to the control system, which makes them quick and easy to integrate into the existing system. They also have a very small apparatus which can be taken anywhere to use. So now some of the limitations of the photoelectric sensor using optocoupler. While they offer many advantages, they also have some of the limitations, which include limited range. So the range of a photoelectric sensor using optocoupler is limited by the strength of the light source and the sensitivity of the phototransistor. This can be an issue in applications where the long sensing range is required. So basically the sensing range is limited by the strength of the light source, which actually diminishes or scatters in the environment as the distance increases. Now the sensitivity to environmental factors. Photoelectric sensors in optocoupler can be sensitive to environment factors such as dust, dirt, moisture, which can affect their performance. This can be addressed by using sensors that are designed to be more robust and resistant to environment factors. So, like we had seen in the case of our like we had seen in the case of our sensor, which basically detects smoke alarms. So, in so similar to smoke, if there's environment factors such as dust, dirt, or moisture, they can also affect the performance, which is a very big limitation to using a photoelectric sensor of an optocoupler. Limited object detection. While photoelectric sensors in optocoupler can detect a wide range of objects, there may be some objects that cannot be easily detected. Uh, some objects might be opaque or translucent for some range of the EM waves, while other objects may be opaque for the same range of EM waves. So that is a limitation of the photoelectric sensors in optocoupler. So now I will talk about some of the innovations that are coming up using the photoelectric sensors and optocouplers, and they have a very wide variety of innovative applications and still continue to evolve with emerging technologies. Some of them are autonomous and self-driving cars, which are they are basically using sensors and cameras on autonomous vehicles to detect and identify objects on roads, such as other cars, pedestrian, and road signs. Agriculture using drones. So photoelectric sensors and optocouplers are used in smart agriculture systems to monitor soil growth, detect the presence of pests and disease, and monitor the crop growth. 3D printing is also coming up nowadays as a very innovative field, and photoelectric sensors and optocouplers are used in 3D printers to detect the position of the print head and the location of the print bed. So now, as we can see in this slide, and particularly in this photo, a car uses a multiple of photoelectric sensors to detect objects around it, that may be cars, pedestrians, road signs. This is a human, and almost every part of a human body can have a photoelectric sensors and optocoupler to basically detect some part, such as a smart finger, a smart glasses, smart watch. And in this photo, as we can see, in agriculture, they are very widely used to basically detect pests underneath the soil, or basically stones or other hard materials where agriculture may not be that good. We can detect them using a photo electric sensors and optocoupler. So that was all from my side. Thank you. I hope you liked it.